All right, guys, good evening. Welcome to this session.
Good evening, sir.
Evening, Ben. Welcome to this session. It's a one-off session.
Long time.
Hey, Richard, good evening.
Yeah, we thought you have sent us to Siberia.
I've always been here.
We thought you have sent us to Siberia. Let's go and figure out ourselves.
It's a teamwork. I've always been around.
Yeah, nice to have you. Nice to have you. How is family? How is everybody?
Yeah, everybody's fine with thank God.
Mhm.
Raymond is competent. He has everything. It's only when he says he needs additional help on behalf of the training that's when I step.
We appreciate him. He has
All right.
done a great job.
That's good. Good to know. All right, so we just basically rub minds here. You ask questions, we interact as much as possible until there are no more questions to ask. And if we are not able to take all of the questions in this single session, don't mind holding another session until we have all of the curiosities from everybody down and everybody's. All right, so let's share screen. So this is mostly about interaction. It's not really the regular class where I take a topic and then we start teaching. Like you already covered the courses. So let's interact as colleagues, especially from the perspective of what should you expect at the interview. But before we go into specific, let me just give you an overview of what you should know now before you talk about actually going for interviews. Then the process, if there is anything that I mentioned that you should know that you do not yet know, if you ask, then we can now quickly zoom onto that part, and then it means calling up the notes and doing the practical just to ensure that you know everything you should. All right, so let's go to Paint, and let me try and give you a picture of what is expected of you at this stage of claiming to be a DevOps engineer. Okay, so as a DevOps engineer, I mean, your resume says you're a DevOps engineer. Sometimes this is not only called that specific role. It could be called cloud engineer. It could be called one of 12 or 13 different titles. But basically, it says that you understand the concept of DevOps engineering, and then more specifically, the tools, the processes, the workflow that you have been trained on. And the workflow is something like this. So if you can see my pen brush, you are expected, yeah. At this level, yeah.
Are you recording this video?
Yes, we are recording.
Okay.
Yeah. All right. You can see my pen brush, right?
Yes.
Okay. So what you're expected to know at this time, you are expected to be familiar with at least one cloud platform, preferably the most popular cloud platform, which is AWS. If in addition to that, you also know other cloud platforms like Azure and Google Cloud, yeah, it would be awesome. But essentially, I mean, fundamentally, we should know the father of cloud, AWS. So this is what we attempted to learn with the course we called AWS Solutions Architect. AWS Solution Architect, remember that course? I think that was the second month of training. So as a cloud solutions architect stroke DevOps engineer stroke whatever title you may want to call that, it means that you are familiar with this cloud environment and you are able to set up infrastructure here. Infrastructure could range from setting up servers to setting up storages, to setting up databases, to setting up virtual networks, and all of that. Security gates, I mean security groups, VPCs, yes, and so on and so forth. All of those unique resources that you learned to create in AWS, you are expected to know all of that and be able to implement that. At this level, within the graphic user interface, which we generally call console in the cloud. All right, so it is expected you're able to go into console, and then you're able to do all of this. One. Then two, going into console to set up all of these resources one by one is one thing, but that is only at the elementary level, at the introductory level. For you to say, I am now right for tech role as a DevOps engineer, you must also, in fact, more importantly, you must be able to run all of this from your command line interface, which is usually integrated within a bigger development environment called IDE. And in our own case, we have chosen to use the specific IDE that we call VS Code. So what are we saying? That you should be able to run codes, scripts, commands within your CLI and IDE or stroke IDE, they could be the same thing, so that without necessarily coming into console, you can run all of these scripts here to automatically deploy the resources, these same resources in cloud. So two ways to deploy resources, to provision these resources. One, you come to GUI, that is basic. And then two, you go through CLI, that is the expert level, the advanced level. So to say you want to go to interviews for this role, it means that you are talking about being able to deploy these resources from the advanced viewpoint. In other words, you know how to use infrastructure as code. The most popular kind of infrastructure as code, as far as provisioning resources in cloud is concerned across all cloud platforms, is Terraform. Yeah, there may be other infrastructure as code, scripting or automation languages, so to speak, in quote, such as CloudFormation, Puppy, Chef, and so on and so forth. But the most popular of them, when it comes to interoperability amongst multiple cloud platforms, it will be Terraform. All right? So you know how to do these things manually or using GUI to do it. You know how to, or where to get the codes, where to download the codes, the documentation to go, or the AI to use to generate your script. And then you know how to run those scripts in your IDE so that this infrastructure and these resources are deployed in cloud. All right? So that is what makes you a cloud solution architect. Fine. On top of this, you also now haven't learned how to do this. You are also now expected to be able to relate the activities, the purposes for which you created all of these resources. You didn't just create them to say, I know how to create them. You created them so that, for example, an application can be deployed inside here, a database can be deployed inside here, all of your company information, data can be stored inside here, and so on and so forth. In other words, you will now need to collaborate with other units of your organization, with the developers, with the network engineers, with the database engineers, and so on and so forth, so that you are now able to give all of these people access to the resources that we have created here, these resources. Operating from here, this is your old place where you are operating from, because you are not necessarily signed into the console to be able to do all of this. All right? So I'm assuming you already know this as well. So what I'm saying is this. I'm saying we'll be working from here rather than working from here. That's just the whole English. We go to AWS, for example. So this is the console. We log in, sign in now, and then we are working by using our mouse to click stop. That is the console. Compared to we are working from here, and we are just writing scripts and codes to do the work here. That is the CLI, right? So at this level, you are going to interview with this knowledge of being able to deploy resources from here. Not with this knowledge. of being able to sign in here. No. Nobody gets job by being able to sign in here and being able to go there. You should know how to do it before you can understand what you are doing here, but it's not enough to get it. All right. So let's go back to the drawing board. So specifically, we are talking about being able to support this unit of IT, this department of IT. The one that really concerns you mostly is the developer. Developers. Right? So these developers, you should be able to set up a system that will take the codes written by the developers. Right? So the codes are here. The Java programs, the Python programs, the Node.js, whatever programming language, whatever SDK, that code is written in it, they are saved centrally. That central place where these codes are saved so that they are now centrally available, even though 50 of the lines were written here, 300 of the lines were written here, 200 were written here, 1 was written here. Altogether, these 551 lines of code are saved centrally here. Right? So there should be a system that takes these codes, build the codes into artifacts, and then take this artifact, build it into image. I mean, this is the process as you have learned it. Save this image into some space called image repository, or more specifically, container registry. And then at every point that we need to deploy this image from container registry, for example, ECR, or what's the most popular container registry, Docker Hub, they should be able to pull it from here and then deploy it into these resources, this infrastructure. So it is one thing to be able to create this infrastructure. It's something else for the developers to work on their own. Then it's something else to be able to work with the developers on one hand and work with operations on the other hand, developers and operations, so that the codes that they have written, you are able to convert the codes into application and then deploy the application into operation. So all of these steps together form a process that we need to not just deploy once, but automate, so that every time a developer takes a code and pushes to our code repo, for example, GitHub, then it should automatically trigger a chain of reaction that will build a new artifact, build a new image, take the image, save it there. I mean, this is just a simple workflow. It could be more complex than this, where we are saying a copy of this should be made into JFrog, and a copy of that should be made into SonarQube, but let's just keep it simple, all right? So ultimately, having understood how to do this, and by your knowledge of Git and how to use Git, you understand not really the details of coding, but how you can work with developers to edit and work with codes. And then majorly, you're able to set up this whole, what you call pipeline, to take the codes and build them into applications and deploy, and then automate that process using CI/CD pipeline, CI/CD. This is what you are taking today. So questions that we'll be rehearsing today, depending on what the area the questions are coming from, would have to do with steps that start from here, after the developers have the codes ready, all of the different steps that we may need to take, and all of the different processes that we may need to build up. It's basically called CI/CD, in order for us to now deploy that code, convert the code into application, and put that application in operations, where it is now available to the whole world to see. All right? So questions are going to come from around 1. Tell me, show me this interviewer now. They are going to ask questions to give you the opportunity to prove that you understand this whole concept of cloud, what happens in here in terms of setting up resources and so on and so forth. You're going to ask questions to learn how you are able to not build these resources in console, but use CLI to write and implement codes that will build these resources. They are going to ask questions that will tell them that you know how to interface, how to collaborate, how to work in a team of developers. Maybe not all developers, maybe we'll have one security engineer there, maybe we'll have one database engineer there, and a team of 15 people made up of 7 developers and other subject matter experts. And then most importantly, fundamentally of all, you want to really ask questions to prove that you understand the workflow between codes and deployment to operations. All of the steps that we talked about here. Did you use Maven? What tool did you use here? What did Jenkins do for you? And then after Jenkins, what as many tools as were involved in this automation process, and even your coding of CI/CD, they want to know as much as possible so that it doesn't look like you just read it somewhere and then you are coming to interview. You just pour down what you have read. You want to know if you have done these things practically. So because they are looking at the whole scenario from the practical perspective, it will be really, really useful for you to show that you can work in this environment. If they ever give you an opportunity to show, to prove, to learn, okay, all of the answers you have given, they seem to be on track. It looks like you understand the workflow, you know what you are talking about. But can you show us something to demonstrate that this is not just theory, this is practical? Then, if you ever get that kind of chance, this is what you will expect to see, this kind of environment. Again, not this environment where you are logging in to class and then you are saying, not this environment. All right, so you don't have to wait for me to log in. All right, so that is the overview of what is expected of us. So now that we have an overview, we can see the big picture of the knowledge that we should have, the knowledge that we are taking to interview. We can now begin to zoom in, maybe at this level first, and look at what you should know. You can ask questions around there. You can ask questions around the different, the workflow generally. And then, of course, that will lead us to talk about the different steps that are involved in setting up the CI/CD. You can ask questions about operations, although that's not really our focus. Our focus here is mainly about the integration of development team with operations team and all of the tools that are involved here. That's the focus. But if you ask questions around here, I can take them. If you ask questions around operations, we can still take them. All right. Did you get that overview? Any question at this time? Hello? Can you hear me?
Yes, I can hear you.
Hello?
Yeah, I was asking if you could hear me.
Yes.
All right. So this is not I'm not teaching. No. You have covered all of this. So it has to be interactive for me to know. Otherwise, I'll just be repeating what you already know, and that will not help. So it really has to be interactive for me to know which area to throw more light on, which area to focus. All right. So so let's look at what we shared on. What did we share? We shared a sample interview with a question. If we go to DevOps, yeah. Kubernetes, technical question. Okay. Yeah. All right, so this is basically like a database of interview of questions from where most in fact, typically all interview questions will come from. Right, so depending on the scope of the interview, some roles will require you to know to have a broader knowledge of the technical concept than other roles. Some roles may just focus on CI/CD, automation, and then they really drill you even beyond the questions that we have here. Some roles may want to know, okay, what do you know about cloud? What do you know about the general concept of IT and cloud generally? And then before now focusing on the area where they are heavy, right? So this is the part where we talked about CLI. So those are general questions that you should be familiar with. I mean, they are not things we'll learn in class because they are things that you should have picked up over the last 6 months. A bit from Linux, another part from AWS, another part from infrastructure as code, and so on and so forth. We haven't learned all of that like we normally see. The focus for CI/CD is usually on the pipeline itself, CI/CD pipeline. All right, so a day in the life of a DevOps engineer for people who have not worked before. I guess there are many. So typically, you come to work. I mean, they may ask you, can you share a typical day as a DevOps engineer? What would you normally do when you resume at work as a? I mean, just a typical day. Doesn't have to be the first day or the last day, but just a typical day at your work. So we have what we call daily stand-up. It's basically a meeting about the project that is ongoing. So there is always something to do. The team always has something to do. So that they are developing a new application or they are, and which could take months and years to complete, or they are working on the part of application that is already developed, or they are adding a new feature, or there's a feature on that application that is not working to customers' requests and they are trying to modify. All right, so there is always this meeting where all members of the team, the DevOps engineers, usually you have one DevOps engineer in the team supporting the entire team. So the developer, the Scrum Master is there, the other subject matter experts are there, right? So you join this daily startup meeting where the Scrum Master is essentially not the technical person, but the person that understands the project. He knows this application that we are developing this week or within the next 4 weeks. We want to ensure that the payment gateway is ready and is attached to this application and is working fine. So he's leading the entire team to work on the part of the project that is going to make that possible, right? So usually it will come in sprint of two weeks. Within the next 2 weeks, let us define what, based on customers, based on the breakdown of the whole project, what do we want to do in the next 2 weeks? And then they motivate and encourage everybody to focus on that particular part of the whole 5 years project. And then they would guide this meeting to focus on that. So the product owner may or may not be there, but where he's not there, the Scrum Master will supervise, right? So provide updates on the task completed, what you plan to work on today, and then is there anything that is blocking you, that is delaying you, something that you ought to do, but because the network guy has not given you an IP address to use, for example, you are not able to continue to do it. And you discuss this at the meeting. Everybody will have a time slot to just talk about, okay, any challenges, everything going on fine, what's your contribution? And then we'll now, together, the team will review the sprint, collaborate with developers, with the QA tester, with the software tester, whoever makes up that team, and then other engineers to discuss the progress of the particular task project that we are running now. Because the whole project, the particular part of the project is this thing. The whole project will be divided into hundreds of sprints, but we'll take it sprint by sprint. All right, so it will be a good idea to understand that, okay, usually when you report to work, whether offline, on-prem, or remote, then there is this meeting that you'd have using the company software to have that stand-up meeting. All right, so step 2, monitoring and incident response. Again, this is not really general, but just a guide, a typical day. Doesn't mean that all DevOps engineers must have similar job roles, right? So check monitoring dashboard, review real-time metrics and alerts from tools like Prometheus, Datadog. So these are, in your own case, you have learned how to use, at least you know how to install. You have a feel of Prometheus and Grafana. So look at your Prometheus and Grafana and see, oh, is there something that requires urgent attention, right? In security, we call those alerts. There are alerts that are critical. You want to quickly clear them and make sure that whatever needs to be done is done so that the application, for example, in an application that is, maybe you work for a consulting firm and then you have so many customers. For some customers, you are developing applications, they are not in production yet, you are still at the development stage. Or maybe for another customer, you're also maintaining their application that is in production. For example, maybe American Airlines, your organization is contracted to American Airlines, and then you are monitoring the alerts on the website just to make sure that the application does not suddenly run out of memory. The server hosting the application does not suddenly run out of storage space. We want to monitor to make sure once the storage hits a particular threshold, maybe 75%, and then the alert is generated to warn you. Maybe you are the person who should do something directly. Maybe you should escalate the case to the people in charge, but at least we want to monitor and make sure that everything is within below threshold so that the application does not suddenly be always fully available. And then if you find anything that should be resolved, then you are within, if you belong to the response group that should resolve it, you do. If you do not, then you escalate to it. Then you take mitigation steps. So everything is talking about the same thing. For example, rollback recent deployment. For example, yesterday evening before you closed, although there'll be not even yesterday evening. So you are just taking over this morning and you just realize that the deployment that was done just before you took over is has rendered the application unstable. So first, second, third customers have just called in to say, oh, we're trying to book a flight, but the application is, it's because we upgraded, we ran an update yesterday or maybe a few hours ago. Apparently something about this update is not working fine. So we need to roll back to the last application that was stable, that was working for that rollback. I'm sure you talked about that in Kubernetes. This, right? Again, this is not only you. Somebody may have noticed it even before you, and then that is where we'll now talk about raising ticket. What's the third? All right. So if that issue came up and you are not the first person to, even when you are the first person to notice, you may now raise a ticket to say, oh, there is this error, there is this problem, there is this issue that needs to be resolved. So usually it will be the Scrum Master and people that are on the non-technical table that will build the ticket and say, for example, this customer has requested that the color red on the application be changed to color blue, and instead of dollar, the currency should be pounds, and so on and so forth. So this one will be put there as a ticket. So maybe your work that morning to pull that ticket. Oh, this one, oh, okay, it was because of the code that I need to resolve this issue. Or maybe it's not my issue, maybe it's the developer. Of course, usually the tickets will be assigned to the person that should take care of it. But if it's not assigned and you feel that you can take care of it, you can assign it to yourself. So the ticketing platform, the place where these tickets are generated and posted so that any member and all members of the team can pull a ticket and work on it, right? We say the ticket is open, and then once they finish working and they have resolved the issue, they close the ticket. We say the ticket is closed.
Excuse me, sorry. What's the full meaning of Jira?
Jira is a platform. The full meaning I don't remember. I'll have to Google it. So it's a platform like ServiceNow, Jira, a job board. So what they do is they are like the applications that enables you generate ticket and put it there for your technical team to pull and resolve. So Jira is one of such applications. A job board is another one. ServiceNow. So Jira will be coined from the name of the company or the organization that has that application. So your organization will subscribe to them and pay them something every month just for them to use that service as software as a service as given to them by that. A job board is another one. Was that the question? But for J means this, I means that, no, I don't remember. But do you know what it does now?
Yeah.
Okay. It's not just Jira. Jira just happens to be popular. A job board is another one. ServiceNow, and so on and so forth. They are just ticketing systems. So when you report to work and you say, I need to sign on, I need to work, this is where you sign on to, and then you see, I think we have a picture of, this is where you sign on to, depending on which of them your organization is using, and then you now see all of the tickets. Look at this. The hard disk is full. I need to create another hard disk so that we can move this. This is where you see that job should be done. Again, if it's not your work, the person who is an expert in that area would see it and will pull it, or it will be maybe specifically addressed to that person, will be assigned to that person. But the one that is your work, that they always look onto you to complete, is this one that is related to CICD. You are the expert there. This is what you spend the last 2 months now. When is this work that is related to CICD, somebody else may do it, but ultimately you are the key person, you are the subject matter. All right, so okay, let's go to step 3. CI/CD pipeline management. So like we said, anything that has to do with CI/CD, in other words, taking the code from the code repository. Give me 3 examples of code repository: S3 bucket, Bitbucket, GitHub, right? So anything that has to do with pulling code from there, building the codes into applications using Jenkins, and so on and so forth, that is your work. So of course, you definitely want to say that your work as a DevOps engineer is majorly around this building application, and then you want to mention as many tools as possible that you use in the job. So you want to mention Maven here if you are claiming that the applications that you build are Java-based applications. You want to mention Jenkins, that is the central of all of your CI. And then you want to mention as many tools as possible. It's now up to them to say, okay, you mentioned Jenkins. Can you tell me more about what you did specifically with Jenkins? Right? So it's not always about building pipeline. It's also sometimes about investigating any failed pipeline, because the pipeline that is working today may come, for some reason, may not just work the next minute, right? What's the problem? But it worked. So you investigate failed pipeline and then determine the root cause, and then of course resolve the issue. Sometimes you also want to optimize the pipeline.
So can we say using webhooks to implement changes for Jenkins?
Yes, you can definitely mention webhooks here. Webhooks to, what does webhook do? To trigger, to link CI with CD, so that every change in code is automatically results in the build of a new artifact. For that one, I use what did you call it? Webhook.
Webhook.
Yes. Yeah, we want to mention that. It belongs there. So this is the opportunity to sell yourself, to market yourself, to tell them I really know so much, especially if it's already stated on your resume. So it is what you state here that they now say, okay, the way you mentioned webhook first time, for example, they may say, they didn't really get an explanation. Then they come back and say, yeah, you mentioned webhook. What did you say you did with webhook? And then you say, okay, so there is this CI part of this CI/CD where I pull the codes and the CI is completed the minute we're able to do what? We're able to test the code and artifact is generated. From that point, we take the artifact, build it into image, and then deploy the image to operation. That is CD. Between the CI and the CD, something has to happen for the CD to know that it has to take over now from that point. That's it. And so when you explain like that, especially in simple terms that even a layman will understand, then they know that, oh, really, you don't only understand how to deploy it practically, you also know the concept. You understand how this thing is. Yes, it's a good idea to mention. All right? All of the knowledge, Docker, even Kubernetes, if you know the Kubernetes, this is a good place to mention. It doesn't mean that you should just focus on that, and it's up to them. They really want to. If they are heavy on Kubernetes and they want to drill you more in that direction, they would ask. Or just give them an overview that the whole idea is, I know what this is. I have done it many times, and I understand the workflow. In fact, I have used these tools. All right. As for infrastructure as code, Terraform is the main thing, like we already said. However, apart from Terraform, if you know any other thing as it relates to infrastructure as code, this is where to mention. Remember that all of these things work hand in hand. We cannot have this resources, this infrastructure here, without mentioning that we use infrastructure as code to make them possible. So we should mention use infrastructure as code. Right? And if you mention infrastructure as code without mentioning the specific tool that you used for your infrastructure as code, they will ask you, oh, you talked about infrastructure as code, what tool did you use? Right? Automation and scripting is not far from infrastructure as code. Anything that you do and you run on your CLI so that it goes into cloud to do that stuff for you, instead of you logging into cloud by yourself, is called automation. If I wanted to delete this storage resource and I enter the command here to do it, and it does it for me from here, that is automation. The alternative is to log into console, go and look for the resource, and then come and manually click it and delete it. No, nobody will hire anybody.
I'm taking my classes.
So the thing to do is to come here and run the command from here, and then it will go there and delete. All right, so that's the meaning of automation. Automation and scripting. So automation will be, you can run a single command and then it will do it. But sometimes you can combine, if the tasks are many, you can combine all of the 5, 7 commands into one, and then it becomes a script. Instead of running 7 different commands 7 different times, you put them all together as one script, and then you run the script and it perform all the 7. Scripts can be written in Bash, they can be written in Python, they can be written in PowerShell, they can be written in Terraform, they can even be written within Kubernetes. They are all scripts. All right, so in our own case, we talk about writing scripts in Bash is part of Linux, Bash script. You learned how to write scripts in Linux, right? We created, for example, user accounts using Linux script. All of those are part of it. All right. So if the question comes, okay, we understand everything you have said, but here we do a lot of automation. What script do you use for automation? All right. So there is no one straight answer. If it has to do with if the automation has to do with setting up provisioning infrastructure, then I use Terraform. If it has to do with setting up CI/CD, what do you use? CI/CD pipeline. if it has to do with automation of network system admin role functions, system admin functions, where's mine? Then of course you use your Linux commands, your Linux. So script does not mean that it has to be one. It just depends on what and what are you speaking. The scripting language you use here and the scripting codes that we use here, it's not necessarily to automate this process. It's not necessarily the same that we use to provision this. And that is not necessarily the same as we use to, for example, change the operating system that is running within this server. This one will use Linux, this one will use Terraform, this one will use CI. I mean, pipeline, just call it pipeline. And then for continuous security, this is not really your work, but usually there will be another department. And okay, we can, even though it's not your work, we can explain the place of that. So the place of security here is that once you have this workflow, you want to ensure, the organization wants to ensure that this workflow is robust, such that the codes that are pulled from here, you don't just pull the codes here and then you just take them straight to artifacts to view. So what you may want to do is take the codes here and scan the codes. Make sure that the codes does not contain any bugs or any hidden bomb or any vulnerability before you now convert it to artifacts. All right? And then once you convert that artifact to image, and then before you save the image to this organization's image repository, you want to again scan the code, pass the code to a scanner. You scan for any bugs, any vulnerabilities, make sure it is clean. If it is not clean, to return it to where it's coming from and say, you want to, this is 99% right, but there's a bug there. It's going to destroy this whole pipeline within the next 1 year. So fix it. And then it comes out pure, clean, before you now say, oh, it's good now. Now let me convert it to image and save here. So this introduction of these security measures, scanning the code, scanning the image, ensuring that whatever ultimately go into production, into operation, is clean, is error-free. That is what we call security. When we are scanning the code, when we are scanning just the codes, when the codes are still raw, we have not even converted them to artifact, just the raw code. We call that kind of scanning SAST, which means software static application security test, right? Whereas once we have converted the codes, they are no longer bare codes, they are now image, they are now applications. Before we now run the test, we call that DAST, Dynamic Application Security Testing. So that's what we have here. At least you should know that in theory, even though they will not ask you, because you are not applying for the role of DevSecOps. But if you are applying for the role of DevSecOps, they may want to know, okay, what tool do you use in this scanning? What tool did you use when you did your SAST, Static Application Security Test, right? That means you are using raw code. In that case, you should know that the tools that are usable there, examples, of course, there are always many tools. Examples of such tools will be SonarQube, Checkpoint. As for DAST, examples will be OWASP, ZAP. Or this is majorly for people that are in security class. Or just enough for you to know that the application security guys are working with you, and therefore it is their role and responsibility to do this part of SAST and DAST. So somebody else does that, or you just focus on building the CI/CD part.
Sorry,
yes.
I want to ask you a question. Still on that DevSecOps, that security issue.
Okay.
Can we also say implementing of IAM rules restrict users based on group, based on projects, based on roles.
Yes,
Just
that is also
to
part of security.
okay.
But it's not part of SAT and that, but it's part of, security is broad.
Yes.
So that part that you just mentioned, the IAM security, has to do with the part of security that is responsible for identity management. IAM means identity and access. So everything we have here now, if we now want to decide who and who should have access to all of this, let's say we have all of this again in our cloud. You can see. And then we now, of course, at the entrance of this system, we have our maybe Active Directory. Active Directory. So for every user, whether as customers or as in-house user that wants to come into our infrastructure, normally they will connect through some endpoints, maybe through their tab or through their mobile phone or through their laptop. Right? You call this on the user, you call this on the endpoint, you call this on the network. So there's security around the user, security around endpoint, and then once they come here, this system will make sure that they are identified, authenticated, authorized, and then once they are allowed in, they are audited. So that your contribution is talking about the kind of security that we carry out here to ensure that only the right users are allowed in to access, only the right user are allowed in, that's identification, and then only the right users that are identified in terms of they already have a user account on the system are authorized to come in. And once they are authorized, they are authenticated to come in. And once they are authenticated, they are authorized not to go to everywhere they like, but only specifically to go to certain resources. And everything that they are doing while they are within here is being monitored. And so your IAM is, that is the role that it plays. So it says that plays the role here. Unlike there's security here, there's security here, there's security here, there's security here. Even within here, we are going to come to public network, private network, and we're going to have, so there's security everywhere. So the part of security that is related to this one is what we call higher. All right, well, good question. So that is not, if your question is that part of your work as a DevOps engineer? No. If you know it is an advantage.
I'm talking about the security part of it, where you credentialize, engineer based on roles and function. You give them credentials since it's you are limiting the roles and what engineers can do or team members can do, or
No, I didn't get this part that you just.
I'm talking about IAM roles where you give your credentials to monitor what people does, since it's also part of security.
Yes, that's what we just explained. That is part of security, yes.
Yeah.
And then we said, but security is wide. It is not part of this, the security that we call SAST. It is its own security.
Okay.
It is not part of this one.
Okay.
And it is not part of that. That is its own security. It's another department of security. SAST is another department. Network security is there. Application security is there. Database security is there. What else is there? SOA as security is there. Theme as security. So security is wide, but this part of security is a different part of security that is not necessarily your own work. Can you see now that your work covers what happens between here and here? So yeah, so we just confirmed your contribution that yes, it is part of security, but it's not within the scope of the securities we are discussing in DevOps. Outside that, yeah. All right. All right, so and so on and so forth. To be honest, I just the contributions that are coming in, I appreciate them. If they come in like that, it will just help us. Because if we just talk without relating them to real life issues, it will just be too theoretical. But basically, again for the last time before we leave here, our work as DevOps engineer, 80% of the work is focused around here. Of course, this is also a core part of DevOps engineering. These other parts are just mostly theoretical performance and scalability. That's part of collaboration. These are just documentation. So the real thing you should be talking about is how you use infrastructure as code to create infrastructure, and then how you set up your CI/CD using the tools that you mentioned earlier on, and then how on a typical day you pull the jobs that you have to do, depending on what jobs is available to do from your ticketing application. That could be Jira or this, and then you do it. All right. So now it's time to take specific questions. If you have questions as to what if they ask me question about this, how would I reply? What about this? Or if you feel that there is another part that you are interested in that we have not mentioned here, this is the time to make it. And if there are no contributions, I will not ask you the question.
Can you tell us a bit more about planning? Let's say you want to onboard a project. What planning,
Want to onboard a project?
Yeah, let's say you want to onboard a project for a client.
Okay.
What planning is involved? Because we know that we have to have a series of meetings with the stakeholders to find out what they want, what they want to achieve, and how you can tailor their demands based on their budgets.
Oh, okay. No, that's not it's not 1 month's work. Remember this meeting that we talked about? It's part of what they are discussing. American Airlines just called us this morning and they have changed the requirement for so thing. So instead of doing it that way, this is the new way we are going. So the person that is in charge of that is the Scrum Master / product owner. So they know the plan. They know even where this project is going in 5 years. They know. You are more like you are in operation.
Okay.
Operations means day to day.
Okay.
You don't even know what is going to happen to this project in 1 month. But the GRC, the governance of this organization, the top executives, the Scrum, up to the level of Scrum Master, these are the strategic people that know where this organization and this product will be in 2 years' time. So it is their work. So whatever they have on their, as part of this long-term plan, which is called strategy, that is what they release to you on a daily basis on the job board. Saying in the next 2 weeks, out of this 5-year plan, this is what we are going to do. They take it from that, and then they convert it to task, and then leave the task on the job board. I think another name for this would be job board. That's why it's called a job board. But basically, you get the point.
Yeah.
So yeah, you now may be part of the team where they are now telling you, yes, because of this change in this project, rather than going in direction A, we'll now go in direction B. Before we're talking about using Jenkins to do this work, but now because of this new requirement, Jenkins cannot do that work. We need to go and learn how to use a Confluence. There's a new tool that has the capability that they are requesting. We need to go and learn how to do that. So all of those changes, they are in charge. It is not you. And then they will now be giving you those planned strategy, long-term strategy in bits on a daily basis or on a weekly basis. But don't worry, as long as you are part of the meeting, that's what they discuss at meetings. Just talk. And then ultimately they now say, okay, now that you have understood where we are at, all right, so let's go back now to our different laptops or our connections and go and implement what we need to do. It is that plan, and there's always plan. There's always plan. Whether they are making changes to plan or the plan that they had before did not actually work as they conceptualized it on the table. In practice, it's not working like that, or it worked, but there's always something to do. Always. Even when it's working perfectly fine, there might be need to still make it fine, work better. right? For example, as at the time it was, the plan was initiated, maybe there was no, the latest tool on chat available was ChatGPT version 4. And now with ChatGPT version 5, there are better and faster ways to do things that we did it 2 months ago, and therefore we need to. So yeah, things would always change. Yeah, well, so that's how it works.
This DevOps is broad.
Yeah, DevOps is broad. That's why they are paid well.
Man.
It's broad.
Let me just pray that when I'm going to go for interview, let them just ask me what I know, what I can talk on.
Yes.
Rather than ask me something that I don't understand, like I will maybe skip my memory. I don't know. That's my prayer.
Yeah. So if to prepare to answer that prayer, then I would strongly advise that to focus only on this. Well, maybe not only, but whatever you focus on, you should really emphasize. Okay, let's add this.
I believe you. I believe you. I will focus on where this place that you are. That's
this one.
Yeah, that's.
So this is the core one, CI/CD. Know everything about CI/CD. Know what Docker is and how to use Docker. And then, of course, infrastructure as code. If you don't know how to set up your infrastructure in cloud, then where are you going to deploy this application? And then automation. Automation is part of infrastructure as code. So that is one part of automation. There are also other parts of it. In fact, infrastructure as code has automation using Terraform to set up. Who can tell me the automation part of where is it? So this part, here has automation. This part here. And the automation that we do there is infrastructure as code, which means we deploy our infrastructure using code. So who can tell me what is the name that we call the automation that takes place here? Because if you remember, we called this one automation. Right. So the automation that takes place here, what is it called? Is it also called infrastructure as code?
The CI/CD, Jenkins.
It's called CI/CD. Not Jenkins. It's called CI/CD. So CI/CD is correct. So in what language or what tool do you use to create your CI/CD? So back here, for infrastructure as code, we use Terraform. So how do we create our CI/CD here? In order to say, we have automated our CI/CD. What must we have in place to say, we have automated our CI/CD? In operations, when we say we have automated ours, remember that automation always takes place here. So, right, we are here. What do we need to have in place here to run here? And then it will work for us to say we have automated our CI/CD. Anybody? Anybody? It's only Richard that should I take it that it's only Richard that understands what we have done, or the rest are just busy? It's not that you don't understand.
I am here.
It's not only me.
Yeah, let me feel you.
Yeah, my guys are listening.
Ben.
I think it's Ansible.
Sorry?
I believe we will have to have Ansible installed for us to do the automation.
Automation here.
I'm sorry.
That's not the answer I'm looking for. Yeah, Ansible is part of automation. In fact, let me put that one aside and come back and ask you, what is the role of Ansible in this whole thing? But right now, Ansible is not the answer I'm looking for. The answer I'm looking for here is, what do we deploy here in order to say we have automated our CI/CD? What we deploy from here is CI/CD pipeline. Pipeline is our automation. Have you seen pipeline before?
Yes, CI/CD pipeline, yes.
Yeah, so that is the pipe. So pipeline wants to write it out as code like this and we'll run it from here. It will do this complete CI/CD, everything from beginning to end. It will do it. It will automate the whole process for us. So when you claim that you can do automation, then you must be able to do automation to deploy your infrastructure, and then you must be able to do automation to deploy your application inside that infrastructure. that deployment of application to the infrastructure is done using CI/CD pipeline. So pipeline is the word I expected you to add.
Okay.
Pipeline. So when we say automation, you see that we're already counting different kinds of automations. And then you mention Ansible. Yeah, Ansible is also another way of automation. What does it automate? You can tell us. We've mentioned different kinds of automation, but now we are saying there's another kind of automation called Ansible. What does that automate? Where do we need to mention Ansible in automation? All right, let me assume that you do not know. All right. So when we have our coders, our developers working collaboratively, and then they contribute all of their codes. What's the name of this place? Just give me a name for this. This developer 1, developer 4. What is the name of this place to which they all write their code?
GitHub.
Okay, GitHub, GitHub, thank you. And then the general name for spaces like this where codes are version controlled, what's the general name, even though the specific name in this case is GitHub?
Let's say source control manager.
Source control manager?
Yes.
Any other name?
Version control.
Version control system. Correct. Source control manager, version control system. Any other name? These are good names. Yeah, this is the interview now. Just give me one more, and then we'll move on.
GitHub.
GitHub is the specific name. You could use a
repository.
Yes. Repository for what?
For clients.
Code repository.
Code repository, correct. All right, so that's good. We are contributing now. All right, so code repository, version control system, the other name that you mentioned, yeah, they are all correct. And then what tool can we use for that? We can use GitHub, we can use Bitbucket, we can use S3, and so on. All right, beautiful. Now, we'll take this from here. So in our CI/CD pipeline, because this is at the first interview before they even say, you are good enough to progress to interview. This is what you must explain. This is compulsory. You must explain that you understand this whole workflow before they can now say, oh, okay, the recruiter, the first call. Before they now say, okay, since like you are a good fit for this position, I'm going to book you for the interview proper. So these are the first questions. They will expect you to explain this whole workflow. Explain the entire workflow. There's no two-way. This is compulsory. Because the recruiter is not a technical person. So he just needs you to explain this in a way that makes sense to him or her before he now recommends you for. All right, so let's go on. So what's the next thing here in this workflow, in this step? In order to ultimately create an application that will be deployed to cloud, what's the next thing here?
You have to pull the source code from the.
Pull the code and then do what?
Pull the source code into
the artifact.
Build is the next one. So you build it into artifact. So build is the word I was looking for. Build the code into artifact. All right, what's the next thing?
Create an image.
All right, convert the artifact into image. Thank you. What do you use to build the artifact into? What do you use to build the image into artifact? Anybody? What tool?
Maven.
Maven, thank you. Maven is not always correct. In what case is Maven correct as a tool? When the code is written in Java.
Yeah.
If the code was written in Node.js or any other programming language, then it will not be Maven. It will be a different kind of building tool. So Maven is correct because we are talking about working. All right, beautiful. So image. All right, so convert that to image. Beautiful. What tool do we use to convert artifact to image?
Jenkins.
You should know this tool, though. If you don't know this tool, Jenkins is not correct.
Nexus.
What tool? Huh?
Nexus.
Sorry?
Nexus.
No. Don't guess. Docker.
Docker, sorry.
Docker, very important. Mm-hmm.
Yeah, Docker image.
Yes, that's why I say
Nice.
Docker image, because it's
Dockerized
Docker.
Image.
Yeah. All right. So now we have the image, right? And then we can decide to just deploy the image straight to operation. Or we can decide that, oh, let us save a copy of the image. What's the general name for the place that will save a copy of the image to?
Docker image registry, Docker Hub.
Docker Hub is a specific this Docker Hub, sorry. Docker Hub will be a great example of the kind of places we can do this to. But what's the general name for? Because it could also be ECR, it could be ACR. So if it wasn't Docker Hub, it could be any other. So what's the general name? Just like the general name for this one is VSC or code repo. What's the general name for this?
That's the image repository.
Image repository, correct. Any other name?
Image registry.
Image registry. Image repository. The other word you are trying to say is container registry. Container registry. Image repository. Those are correct. All right, so this is what you explain to the recruiter, that you are familiar, you have done, this is what you are doing for your organization, and then you are responsible for pulling the image and then deploying it as application. All right, now the question that brought us here, now I want to pull this now. All right, so the question now, the Ansible now, this is where I want to ask you now. So if we're going to deploy this application now, if we're going to deploy this application to a single server, no problem. We'll just do it using Docker, the same Docker that we talked about. But if we are now going to deploy the same application to multiple servers, three of them, server 1, server 2, server 3, at the same time, then Docker can no longer do it. That is when we need Ansible. So Ansible is for configuration management. In other words, it will deploy an image to multiple servers concurrently. It's automation now. Yes. Otherwise, we'll be doing it manually. We'll deploy to this one first, deploy to this one first, and second deploy to... No. But we can just automate the process of deploy to 50 servers concurrently. Our Japan server serving our Japan market, our US server for our US market, our China server. It will deploy the same application to multiple servers. So the information is Ansible. You see where we talk about Ansible now? But if we're deploying to just one server instead of multiple servers, then we'll be talking about Docker. So Docker Ansible, about the same, except that when it comes to multiple servers, then we'll talk about Ansible. All right, so the person who mentioned Ansible, do you see the place of Ansible?
Yes, sir.
All right. So once you're able to explain this workflow from here all the way to operations, and then you may now want to mention that deploying to operations is not the end, that you also want to ensure that, sorry?
You have to manage those images.
Yes, it's already deployed.
Yeah, I see manage those.
So the images are ready.
Yeah, those with Kubernetes.
No, we have not mentioned Kubernetes. We can come back and talk about Kubernetes and the place of Kubernetes. But before we talk about that, what were you trying to? I guess you were trying to add something, but you are not mentioning this.
No, I was saying then to manage all those multiple servers.
Okay, so what we should add here is that the work of a DevOps engineer does not necessarily end at the point where he's been able to successfully deploy to multiple servers. He would now also need to install monitoring tool so that apart from this service now being available globally and the whole world can see it, we are now also able to monitor the applications running in here using monitoring tools. So you're able to set up and configure monitoring tools to monitor them. Can you mention an example of a monitoring tool that you can set up to do this?
Prometheus and Grafana.
Yes. Prometheus and Grafana. Correct. And then based on what you see, you can now get feedback and tell the developers, there's something that is not working right, to change it. Not just you, the entire team. This is not working right. Look at this. It's giving alert, generating alert every 10 minutes saying that something is wrong. Please fix it. And then they will fix it, and then it will go all the way through this steps again. And then it will be monitored until that issue is resolved. And right, so monitoring is the last. So when you talk about your workflow, don't relax after your deployment has been completed. Remember that there's still another part called monitoring. All right, beautiful. Now, what is the place of Kubernetes here? Everything we'll be talking about, we have not mentioned Kubernetes. So, where's Kubernetes? Where's the place of Kubernetes? So this is the place of Kubernetes. Where I can. So instead of having 3 servers managed by Ansible, I can decide. Let me delete it. I can decide that to use a different architecture to deploy this. So I can have only 1 server. But this server will be so, actually, no, not 1 server. I can have multiple servers. And then all of the servers, I will join them together. I will add them all up to form 1 big server. All right. So I'll form a cluster. All right. So inside I have servers, but my interest now, my focus now is now on the community. I'm looking at the whole community together instead of the individual houses that make up the community. So I'm now seeing this as a Kubernetes cluster. Cluster means a village of servers. A village made up of 3 servers. Right? So instead of dealing with this as 3 servers managed by Ansible, I'm now seeing this cluster as 1 complete cluster with so many containers, where each container can run a different application. So I have a container there, another container here, container. So many containers, right? So instead of dealing with 1 server and another server, I'm now talking about 1 container, another container, 1 application running here, another application running here. So I have hundreds. Well, they may not all be running simultaneously, but it is possible now for me to have a Kubernetes cluster running hundreds and hundreds of applications, where each application is running inside a unique container. And the tool that is responsible for creating and managing all of these containers for me is now Kubernetes. So Kubernetes is the complex version of Docker. We have Docker, which is the primary tool, and then we have Ansible, which we use when Docker is no longer simple but complex for multiple servers, and then we have Kubernetes, which we use in the case that I just described, Kubernetes, right? So Ansible has Docker inside, Kubernetes has Docker inside. This is the most robust Kubernetes, right? This one is not really so popular anymore because we find that instead of having 3 servers and running them uniquely, why don't you just join all the 3 servers together and treat them as 1 server, and then the management becomes really, really easy. Because instead of managing 3 different states, you are now managing just 1 federal state as the United States instead of managing 56 different states. It's more complex. I mean, 50 different. All right. So your production environment, to conclude, can be Docker, can be Ansible, or most commonly these days can be Kubernetes. It's our production environment. All right. Just to ensure that we drove that through, let me ask 1 or 2 questions. So I am pulling, as a DevOps engineer for this project, the developers already wrote the codes and we successfully converted the code to image and stored the image in our container registry. So where would the work of a DevOps engineer start here? Is it to pull the image from container registry and deploy the image as application to operation? Is that correct?
Can you say that come again? So you say that again, please. Sorry.
All right. So this job, we have already taken step 1, step 2, step 3, and today, at the end of today, we have arrived at successfully converting these codes to artifact and the artifact to image, and then successfully saving the image in our container registry. So the image is saved here. When we come back to work tomorrow, where should we continue from? Is it that we now take the image from where we have saved it and deploy the image into our operations as application? Because once the image enters operation, it's no longer called image, it's now called application. Is that correct?
No.
So what is correct?
We have to pull the image and test it first. Create like a test server called maybe unit testing or whatever. We test it
So no,
first.
don't complicate things. Within what you have learned here, within what you can do within the 6 months program that you have gone through now, what can you or what have you been taught to do as a DevOps engineer? Don't include the work of other departments. Just your own work now. What would you do now when you come to work the next day?
We pull the image.
All right, pull the image and then do what?
Pull the image and
are you saying this one is correct? We pull the image into operation and then we deploy it as application, and then from that point it's available for the world to see. Is that correct? Any other person?
I'm not too sure.
Yeah, any other person contribute? Don't put one person under pressure.
Yes, that's the next step. We'll pull the image.
Okay, this is the next step, right? Okay, that's good. Any other contribution from
I don't think I have any other contribution.
Okay, so yes. So the next step is correct. We pull, this is only the next step to take. We pull the image that we already saved here successfully. We pull it into operation, and then we deploy. It's called, that pulling that is called deployment. We deploy the image into operation. When an image is deployed into operation, the image in operation is now running as an application. True or false? True. All right. So what was the question that I wanted to ask? Okay. So having successfully deployed your image into, okay. To successfully deploy your image as application into operations, we can do that in one of 3 ways. We can just deploy it as a Docker image, as Ansible, or into Kubernetes. Which one would you use and why? I mean, these are 3 different ways you can deploy images. Just deploy it as a single image into a single application, single image as a single application in a single server. So that is the answer. That's the reason I will use Docker. Under what situation, under what conditions, circumstance would I use Ansible? I've answered one of the questions.
If you just have a few servers.
Sorry?
If you just have few servers, just maybe 1 or 3 servers.
You mean multiple servers? If I'm deploying to multiple servers concurrently?
Yes.
Okay. So if I'm deploying to multiple servers concurrently instead of just one server, then I'll use Ansible. The concept of deploying into multiple servers concurrently and being able to configure these multiple servers from a single center. What is it called in IT, in DevOps?
You say what?
It's called automation.
It's called what?
Deployment.
CICD.
Okay. Continuous deployment.
No. Okay, let me ask the question again. So somebody said Ansible is what we use when we are deploying from one place to multiple servers at the same time. That is correct. So my question is, we are now able to monitor and configure all of these multiple servers centrally from here. We're able to configure them simultaneously. That's the whole idea. The configuration of these servers are now automated from a single point. So my question is, what is this concept called in IT where from one server, you're able to manage multiple servers from a single point? What's it called? It's called configuration management. Configuration management. Have you heard that word before?
Not really.
Configuration management. So can you mention one tool that is used for configuration management?
We just did it, Ansible.
Yes, you just did. Ansible, correct. If you are not replying, I will not know that you are getting. All right. So we have answered two questions now. That we just use Docker if we are deploying to a single machine as a single application. We use Ansible if we want to deploy to multiple machines concurrently and be able to manage all the multiple machines from a central place using configuration management concept. Then the biggest question, when do we use Kubernetes? When do we, what's the ideal situation, the use case for deploying to Kubernetes? The Kubernetes drawing is still on it's still right here. So
when we have multiple servers.
No, you don't have anything yet. It is you that is determining, that is deciding what you want to do. So when would you say, you know what, guys, let's deploy this to Kubernetes. All this Ansible you are talking about, I don't understand. Let's use Kubernetes. What would be your point at the meeting for choosing Kubernetes? Wow.
If there is need to go on the
No, you go on.
Oh, I think it's if there is need to deploy the application in different location that has there's different servers that are in different clusters. That's if you just don't have, if you have more than one clusters, you could use Kubernetes to do that.
Yeah.
Okay. Any other contribution? Yes, more contributions. When do we use Kubernetes? All right, so Kubernetes is only one cluster. So maybe what you were trying to say, if we need to run multiple versions of that application, therefore we need multiple containers because each container will run a different version. Okay, let me not introduce version so that it does. So we need to run what's another word? Version is it. We need to run multiple versions of the same application, but we need to manage all of the containers centrally from a central location. So unlike Kubernetes, unlike Ansible, where we had multiple servers, here we have only one Kubernetes cluster, and therefore all of the management is within one Kubernetes cluster. So we'll deploy to Kubernetes where we are talking about running the same 15, 20, 30, multiple versions of the same application concurrent. Then we use Kubernetes. If, for example, the task is So we want to deploy an application that can scale from 200 users to up to 2 million users. So depending on the system requirement, we may be running only 5 versions of the application, or sometimes even 50 versions of the application. Then Kubernetes will be the best solution. Because in terms of how do we now move from 5 to 10 to 50, Kubernetes will take care of the management of the cluster.
So
the creation and
highly scalable and highly available.
Yes, highly scalable. Always highly available. All right. So
I have a
at least,
question.
all right, yes.
When you say different versions, I assume that when you deploy the application to different servers and zones, it's still the same application, right?
Yes, it's still the same application.
Okay.
So the version does not necessarily mean version 1, version 2, version. All right. So since you're interested in that, let me explain that. So, so we are saying that we have a Kubernetes cluster, and inside this Kubernetes cluster, you have this container, and you have deployed an application into this container. And this application, based on the resources available within this container, can support maybe 200 users connecting to this application. Once 300 users are available to connect to this application, the resources available within this container cannot support 300 concurrent users connecting to it to crash. So what will Kubernetes do? It will create another container automatically and create another version of this container inside of this application inside here, so that we'll now have 2 versions of the same application running here, right? So this is taking 200 users, 200 users. What about our traffic? This is our rush hour. So people are coming to our website, and then we now have need for additional maybe 500 people now. These 2 containers can no longer support 400, maybe 500. So it will create another one. So, so these different applications that are being replicated on all of this, that's what I call version. Exactly the same application, but now scaled, like somebody mentioned. So that's what I mean. And Kubernetes is really good at this, because this idea of how do I know when to create another application, Kubernetes will take care of that by itself. It's very, very intelligent. To take care of that.
Because it's a self-managed.
Yes. In fact, it is the ability to create these clusters. I mean, the ability to create these containers and run this application there. That is why we call it cluster manager, or better still, cluster orchestrator. So Kubernetes, when we say Kubernetes is a cluster, not cluster, container. Okay, this is exactly what we need. It's able to orchestrate. It's able to know, there's work for you. Come, just like a band orchestrate, somebody orchestrating the band to say, okay, you, the flute guy, you soften your input, and then the band guy increase their volume and so on. So, okay, there's need for another container. Okay, you come. There's no more need for that. Okay, you go. So that's how we call Kubernetes, the container orchestration tool. All right, so at this level, you should have if you have just basic understanding of what Kubernetes is and what it does, and then are you able to set up a Kubernetes cluster, by the way? You know the command to set up a Kubernetes cluster? Did you do Kubernetes?
Yes.
Okay. Did you complete this task in class? Where is the task? The one I shared earlier on the forum. You have this note, right? I asked your trainer, I said you have this note. This is the note to share with you.
Yes, we have this.
Okay. Yeah. It's just a matter of understanding everything in the notes. Since you already have the best material. Or if you want, we can take a short break and then come back and execute this project together. Where's the note? We can execute this project together, but I don't think you are really flowing enough to be able to. It's one thing to run the project and get results. It's another thing to really understand exactly what we are doing. One can take a break, come back and run that. But before we decide whether it is worth doing or something you have already done by yourself, you did well when you made your contribution in the setup of CI/CD. But apparently, you didn't do, and then we have learned what Ansible is now. So as for Kubernetes, you are sounding like you are hearing it for the first time. You didn't do too well. All right. So what about CI/CD pipeline? Have you created a CI/CD pipeline before? It's already in the note. Can you copy, paste, and deploy a CI/CD pipeline to automate, for example, the process of deploying, of taking an application here, converting the application to image, and then deploying the application to this? That's what a CI/CD pipeline do. To be able to run, apart from just going to Jenkins and manually clicking stuff, to be able to run a code that does it for you, and then you run the code from here. Doesn't matter whether it's a very simple code or a complex code. At least you should do something. You see that, oh, the application has now been deployed and it's available in operation. Because it's running from
But please, I don't know if we will appreciate if you after the break, maybe you can do it.
Okay, so let's do one
Maybe you can do it through VS Code.
Yes, let's do it.
Yeah.
Okay, let's quickly start it, and then it will get to a stage where it will take 20 minutes to get itself, and then we can go on break during that time. Let's start it now, then we'll go on break. Okay, so which of them? There are many projects in your notes. Which of them do you want us to do? I'm feeling that this one may be too complex for you. Let's do a simpler one. Simpler one may require us to go and set up Jenkins. So okay, let's go and set up Jenkins from scratch. So let us do you have any particular one you want us to do? I thought you said we should do something. You are no longer talking.
No, I was saying the one you use VS Code and set up the
Yeah. There are many of them. So
and it will install on the whatever server that we're using the infrastructure to provide.
There are many of them in your notes. Did you ever practice any one? Is there one that you need us to quickly practice? Can you see my notes?
Yeah.
So which one are you familiar with? That one I didn't understand it. Let's do that one again.
And just pick the one you want to pick.
Pipeline is what I'm interested in. Pipeline. Let me look for pipeline. But let me look for pipe. Which note is this? Is it not DevOps2? Okay, DevOps. Okay. Go to DevOps1 then. Let's go to DevOps1. DevOps2 is purely Kubernetes. Let's go to DevOps1. Okay. Let's go to DevOps1. Yeah. One for DevOps. All right, so let's do it. All right, do you know that the project is divided into two? One part of the project will set up our infrastructure. Then the other part of the project will take our codes, build it, and then deploy it into the infrastructure. Do you understand that? Whew. All right, so let's start the project. So I go to, let me go and start the project. Let's call this project, what's this class? This is, let's call this revision. All right, so revision. This revision class, I'm going to have my key pair, Control C. Then I put it inside my revision, Control V. All right, so I have my folder ready. So let me go to my ID. So what's my ID? With my ID, I close this project that I have open, close the folder, and then let us start a new project. Open this folder that I've created for the project. The folder is called DevOps1 Revision. So that's the folder, and then I save it. All right. So the first thing I want to do on this project is set up my infrastructure in cloud. All right, all of the infrastructure that I need, let's set it up. So I'm going to call this, already I have the code to set up the infrastructure. So this is my infrastructure as code. So I copy provider AWS, I copy all of this code. This is my Terraform, Control C, and then I reduce that, and then I come here and then create a new file, call this file
provider.tf.
Let's call it infra.tf, or maybe even main.tf, main.tf. All right, so I put there the code that I already have, Control S. All right, so let's run the code. We'll go into cloud and provisioning. All right, so where's my terminal? Okay, so go to terminal, new terminal, and then I'm going to work from Ubuntu. This is the correct terminal. Man. Okay. AWS -- version. Okay, so this is the correct terminal I have. So let's run our Terraform code. So ls -l shows that I have my main.tf. That's good. So the next thing is the Terraform init. Yeah, 4 minutes. All right, so Terraform apply minus auto. All right, so this my code may be slightly different from what you have because this is highly automated. So I'm saying create this, and then after you have created 3 servers, look at the 3 servers. Right, so I put there generated by ChatGPT. I say configure one of the server using user data if you did AWS. So here I'm saying configure one of the server with my Jenkins so that it's my Jenkins server. All right, and then I said configure and call that one my Jenkins server. Then configure what else? So put this there. Configure Jenkins by installing Java, install Maven, install Jenkins. All right, Jenkins server. Okay, this one is only installing Jenkins server. In the 3 servers, 2 of them will be free, no installations. Only one will have Jenkins server because I've already done the installation here. All right, so that's fine. So let's see how that goes. This one is still trying to provision that server in cloud and then to install Jenkins. So this is what we're talking about, provisioning your infrastructure. It's going to set up 3 servers for me. The server will be of type T2 medium, and then it's going to configure one of the 3 servers to become my Jenkins server. And then the other 2, it will leave them blank. It will not configure them. All right. This is automation. The automation we'll be talking about. Imagine if this were not already configured, then it will mean that I'll have to manually go into the server to do all of it.
Yeah, that's a lot of problem.
Maybe it's not a problem. It's just that it takes longer time. So if you have 15 different projects, it means for each of those 15 different projects, you have to repeat this thing manually for
Yeah,
how much are they paying?
That's why I said it's a big problem. Imagine having like 50 servers.
Oh, okay, that's what you mean by problem. Okay. Yeah. It's really time consuming and it's prone to error.
Exactly.
But once you do it once, okay, so the 3 servers have been created for us. Look at them. So let's copy the IP addresses, Control C, and then I don't need to come to cloud to check anything. But since you're already here, let me just confirm to you that the 3 servers were actually created. So I just quickly come to running server, and then you see the 3 servers. Well, I don't need to be coming here. Let me just close it. But we're already experts now that are working from here. All right, so I come here and I take note of the IP addresses because I need the IP addresses to be able to connect to the server. So Control V. All right, so the first server we said is our Jenkins server. It's already configured. You know how to SSH into our Jenkins server, into any server from here? It should be in fact, it's in the notes. SSH -I, then Ubuntu at this IP address. What is my SSH key? My SSH key I will get from here. If I do ls -l, I'm going to find my SSH key. That was why I copied it. Look at it. I copy my SSH key, Control C, and then I'll put it here to say, use this key to connect with my Control V. So that's it. That's the command. To connect to that server. So why don't I? Okay, you can stop here. So So I take this command and I say SSH into the server, Control C, and then I come here and I say go to PowerShell, and then I use that command to SSH remotely to that server that I just created in class. And then, are you sure? I say yes. Why? Yes. All right. Go. Awesome. So I'm now remotely connected. I've successfully SSH. All right. So for Jenkins server, let me see. Let's go into Jenkins server and quickly do one or two configurations within the Jenkins server. All right.
Mm-hmm.
So let's quickly go in. To go into Jenkins server, I need the IP address of Jenkins server that has just been created for me. This is the IP address. Control C, and then Control B. And I remember that this is my Jenkins. In fact, I don't even know. Let me even find out. Is this actually my Jenkins server? Let me find out. You are supposed to have installed Jenkins here. Did you install Jenkins? Jenkins minus version. Oh, Jenkins is installed. Oh, that's good. It's Jenkins server. For you to have installed Jenkins, that means you have actually also installed Java.
Mm-hmm.
Java minus version confirms that. And then what?
Maybe.
Correct, Maven. Maven minus version. There's something wrong. Maven is MVN. MVN. Awesome. All right, so now we know for sure that it's our Jenkins server. Now let us connect to the dashboard of our Jenkins server. All right, so to do that, we must enter that server through port 88. All right, that is the door. So we'll copy that, and then we'll go to our browser, and then we'll say connect us to that server, Control V through port 88. And then it says work. Oh, that's beautiful. Our Jenkins is working. So it says the password is saved here in Jenkins server. Go and pick it. So quickly copy that, and then we'll come back to our Jenkins server, and then we'll present that place, and we'll say sudo cat the content of that place. And then it shows us the password. Okay, we pick the password from here, Control C, and then we'll come here and present it and say, hooray, we found the password that you asked us to go and get right here. And then it says continue, and then it says, oh, you are good, install. All right, so this is Jenkins dashboard. So we just set up our Jenkins server, and then we're now configuring our Jenkins server to be able to do the work of Jenkins, because we know the role and importance of Jenkins in CI/CD. All right, so what name do you want to call this? I think I have maybe admin. Let's see. Okay, just do admin. Admin, the item .usc at gmail.com. Oh, that one should have been my name. Okay, just put name here, manager. All right, so save and continue. Admin. Don't worry about that. I don't want to save anything. And then save. All right, so our Jenkins is ready now. So let us start to use Jenkins. What do we want to do with Jenkins? So we just set up, let's quickly deploy, before we even do pipeline, let's quickly do a normal, regular deployment. All right, so we say new item, let's see freestyle, and let's call this basic deployment. Just a basic one. All right, so which code repository, which project do we want to deploy? Let's go to our code repository, github.com. This one, my GitHub account. Sign in the item, but the item .usc at email.com. So I will remember my password. The I. Let me look for my password. Control. Bit of the item. What's my password? Let me try again. Okay. So I use third party author. What? Okay. So third party authentication is to send me code. Let me confirm from my code. On my phone rather. So the code sent to me is 923081. 9230. All right, guys. So this is the GitHub that all of the code repository that all of the developers contributed to. So the particular one we're using here is GitHub Basis. All right. So let us take this one and build it. So we'll come here to code and we'll say so let's go ahead. So we'll copy this. So let's go and present that one as the code we want to build. So between GitHub and Jenkins, we go to Jenkins and we say build this code. I hope you are still following. All right, so build the code from GitHub, and this is the repository. And then it says it's a private repository, so it needs the username and password to be able to access the code. I say, okay, that's true. Okay, let me quickly add the username and password. So I come here and I say domain, provide my username and password in order for Jenkins to be able to access that code. The username is the icon, the password is the password. I saved it in my notes right here. Control C, and then I put the password there. And every time I want to call this particular credential, I'll just call it the item. So let me put the item. All right, so I have declared the credentials. I say add. All right. So look at it here. It's still saying failed. I cannot access. So I come here and I say, I have declared the credentials here. Use it, pick it. Oh, it has gone. It's no longer giving that error. So go and take that code and then do what with the code. And then we'll say build the master branch, and then build trigger. Oh, there's something we didn't do. All right. The first thing we should have done that we did not do out of rush is that we should declare we should define our tools. So we'll come to manage Jenkins. We'll go to global system settings. All right. I'm not sure this is it. Let's go back to manage Jenkins. We'll go to tools, configure tools. So we'll go to tools. And here we define our tools. Our tools are Jenkins, Java first of all. So we'll say add Java. Let's call it my Java. And then where did we have this Java saved? So we'll go back to our Jenkins machine and we'll say, where is our Java? In fact, you can see it here. See here, look at it. Our Java is saved here. Can you see? We'll take there and we'll say, this is the home directory where you will find Java anytime you need Java. We'll put that one. So that one is done. What about for Git? For Git, we are just going to say use the default setting and then leave that one there. What about the build tool? We are going to add Maven. For Maven, we are going to call it my Maven or any other name that you choose. And we are just going to say install the version that you want. We'll just leave that one here. Then we'll say apply. Then we'll say save. Now we have defined the 3 tools that we need Jenkins to use to be able to build our projects into Artifact. All right, so now that we have used the tool, let's continue with what we were doing earlier on that we did. So let's go back to the project that we were trying to build. We'll go back to that project. We'll continue with our configuration. The one that we configured is still there. But this time, we'll start somewhere around here. Build trigger, build environment. We are going to say, build this project using Maven. So we'll come here and we'll say, invoke top level target. And then the goal is to build. What do you call build in Jenkins? We'll call it package. Or package or clean install. The same thing. Clean install. All right, so that's all we want to do. Just go there, pick the codes, and then build it using Maven. That's all. So we apply and we'll say, that's it, it's done. So now let us build it because we have defined the parameter for it. So we say build now. All right, so the code is building. I'll go to the console and see what is going on while the code is building. And the code successfully built into an artifact. So now we have an artifact. And where is the artifact saved for us so that we can go and take it and use it from there? The artifact has been saved as webapp.war in this directory. So that's how to build code, Java code to artifact. All right, so the CI part of the project has completed. The next thing we want to do now is to take this artifact and then we build it into image and then deploy it into production. But this time, we're not going to do it using this method. We want to build it using pipeline. We want to use code to run it. That's the real reason we came here, like somebody. All right, so at this junction, we're going to take a short break, and then by the time we come back, we're going to set up. Let's look for the new project that will enable us to build this pipeline. Look at pipeline. Look at pipeline here. All right. So this pipeline, let's look for a simple.
Do we have this folder? This notes.
This is DevOps1. Did you do DevOps1?
Okay, okay.
DevOps1 is your name. Compare your DevOps1. Where's our? Let me look for pipeline.
I don't think our notes were exactly like this.
Yes, I don't think so.
The scripts that you used to automate the servers from the beginning.
Yeah, yes, that's true because I really especially. Okay, I can share this note with you.
Please share.
All right. So CI/CD pipeline. Wow, this is really. Let me just do the CD pipeline. Okay. So let's do the complex one. So this one is complex. This one is saying the entire CI/CD pipeline, I want to automate it. All right, so I use the ChatGPT to generate this, and then this is what I have. So anytime you see code like this, it will first of all give you the part where you need to do some modification. They are called variables. So these are the only parts that you change, right? If your Docker IP address is different from this, you create you edit it, and then this other part is this CI/CD tool that will do the real work. Look at it. Look at it. That's the CI, that's the pipeline. We'll just take this pipeline, which may have taken us a whole week to get right, or even a whole month, but once we get it right forever and ever, we now have it a repeatable script that you can use over and over and over. All right. So I will continue to work for the next 15 minutes, but I'll give you 15 minutes to go on break so that when you come back, you will meet the new infrastructure that will enable us to run this pipeline. So there are two parts. Before I run the pipeline, I must first of all provision the infrastructure that will support the deployment of this pipeline. And then once that infrastructure is in place, using my infrastructure as code, then I will now deploy this pipeline inside that. Let me look for the pipeline part. The infrastructure as code part for this pipeline. Okay. Where is my Terraform for the infrastructure as code? Is this it? Oh yeah, this is it apparently, because this one is setting up my Docker. So this one will set up two machines. One will be my Jenkins server, and the other one will be my Docker server. And that's all I need. Okay, that's fine. All right, guys, you can go. If you like, you can stay and watch, but you can go if you want. So let me set up 15 minutes timer, and then I'll continue. 15 minutes timer to give you a break will be 15 minutes timer Google. And that starts to cut. All right, so while that one is going on, I'm going to set up a new set of infrastructure. But first of all, let me delete the one that I set up earlier. So I'll go back to the one that I used for demo, and I'll say I'm done with this demo. So I'm just going to say, go back to my WSL. Earlier on, I said create this infrastructure, but now I'm done with the infrastructure. So it's going to be Terraform
destroy.
Exactly. Okay, destroy. Now you have seen how easy it is to set up and destroy infrastructure, provided your code is correct. So while that one is destroying, I want to start another project. The new project will set up all of this. Okay, so I take this code, Control D, set up my infrastructure. Then I come here, just going to continue with this one. I set up a new file. Let me call this one main1.pf. Then it gives me a blank. I save that on Ctrl S. All right, so my script is good, supposedly. So this script is really configured in details, not just to provision the servers, but also to configure the two servers. All right, one has Jenkins, and the other one has Docker. So I have literally nothing to do once they are both All right, so while that one is going on, let me open a new terminal so I can be multitasking. Right, take another terminal. I say, set up this new one. Let me just give this guy 5 minutes to complete his own clearing so that I don't know. All right, so while I'm waiting for that one to terminate, to complete the deletion, I am going to look at my CI/CD. Where's my CI/CD? That CI/CD, I'm not sure I'll be able to do it today. But let me just complete the setup of the infrastructure and then make sure you understand that part. All right, no need to rush. What happened here? Okay. Connection to the server closed because the server has been destroyed. So automatically closed by itself. The server has been removed. Okay, so it's still destroying. Is anybody here with me?
Yes, Richard, I'm here.
Okay, Richard, what are the two parts of automation that happens within CI/CD?
The two parts of automation that happen within CI/CD.
Mm-hmm. You know how to automate the CI/CD process?
Yes, code code analysis, code coverage, and artifacts building.
I have no idea what you're talking about at all.
Oh, can you repeat your question again?
By the way, the ability to understand my question the first time is part of the interview. I hope you know.
Yes, so.
Yes, because you have found us asking me to repeat. Okay, so since this is not the interview proper, I'm saying that in setting up your CI/CD to support your development environment, there are two major automations that you need to do. What are these two automations?
You need to I need to provision my infrastructure.
Correct. That is one.
Yes.
How do you do that?
By using a tool called Terraform.
All right, by doing infrastructure as code using Terraform. Correct. That is the number one answer. Full mark, 100 over 100. What's the second part of the automation? After you have provisioned the infrastructure, what else do you need to do? Would you need to do to complete your?
By running the code to set up my server.
So you automate the provisioning of your infrastructure. That's number one. Number two, what do you do? What is the other part? Is there any other thing you need to automate as part of your CI/CD automation?
I need to automate the deployment.
Oh yeah, that's correct. So how do you automate the deployment? So you've automated the infrastructure build. Now you automate. How do you automate the deployment?
I need to automate by configuring my Jenkins to listen for any changes. If there's any changes, then there should be.
How do you automate deployment? That's not the answer. I'm talking about automation. You automate infrastructure provisioning through your infrastructure as code using Terraform. So in the same way, how do you automate deployment? We've answered this question 2 times today, but because the question is very fundamental to your interview, if you can't even pass that question, you cannot proceed. That's why I'm asking again. Automation. I think you got that. How do you automate the deployment? Any other person hearing me? Please look at your. Huh?
You automate deployment using Docker.
No. So in building CI/CD, there are 2 parts of automation we need to do. We just did it now. So the first part has been answered. What's the second automation that we need to do? We automate the deployment of the application to operations. How do we do that? How do we automate that? That's the question now.
We pull the image, push the image.
We do CI/CD pipeline. We said that many times. Okay, CI/CD pipeline is the answer.
Okay, CI/CD pipeline. Okay.
Pipeline, that word pipeline, that's the key word. Pipeline. So there are 2, that's why we are doing this project. That's why you are going on break, so that you come back and see how to do that pipeline. So 1, you set up your infrastructure automation using infrastructure as code. And then secondly, you set up the deployment automation using CI/CD. Even if you don't put CI/CD, that pipeline is the key word, using pipeline.
Pipeline, okay.
Please write it down. Write it down. If you don't answer that question, the question may not come exactly as I'm asking it. But if you are not able to coordinate your answers logically enough to reflect that, there are 2 parts to this automation I'm talking about, and then you mention them, it will not go far. But if you're able to mention them and say, it really means that you really understand this. Therefore, they are happy to really go on with it. Please write it down so that next time I ask, you get it correctly. There are 2 paths to the automation of your DevOps workflow. Automation of your infrastructure using infrastructure as code, Terraform, and then the automation of your deployment using CI/CD pipeline. All right, we still have 5 minutes to enter. Yeah, let me quickly deploy this before that's come. All right, so now we have this. So it's going to be Terraform init because it's a new project. So we have to do Terraform init all over again. 5 minutes is up. Let's do the first part. Terraform init. All right. So Terraform apply. - auto. All right.
Okay, the CI/CD pipeline is the second part.
Yeah, the second part. If they ask you at interview, do you know how to generate this code that we are using now? Of course, you did not generate this from your head all by yourself. So what is the answer? Where did you get assistance?
I went to Terraform providers, AWS Terraform providers, to get the
documentation. Okay, documentation is one way. Any other way? Went to the documentation and then.
You can also go to the GitHub.
Okay, community supported open source resources. Any other way apart from those 2?
You could go to ChatGPT.
You could go to AI, correct?
Yes.
AI, any AI, code AI of your choice. Could be ChatGPT, Copilot, any of the other ones that are not so popular. Yes, it's very important to mention that you have the knowledge to be able to use AI to support what you do. And then you are up to date by knowing that these resources are there for you to use. And therefore you can compete favorably even with the best coder with the support of this. Don't ever say that you know everything off your head and that you are able to do everything by your hand. All right. All right, so we have this ready. Control C. Then we are just going to do what we did before. Just repeating what we did before. Control V, except that this time the IP address has changed for our Control C for our Jenkins. Control V. This is our Jenkins. This one is our, how do we know when the time is? Then this one is our Docker server. Docker. All right, good. So what do we want to do now? Now that this is ready, I will follow the notes. Okay, so let's go into our Jenkins server and do all this configuration. If we go into our Jenkins server, we are going to do enter Jenkins through port 8080. All right, the break is over, guys. So to go to Jenkins server, we go here, Control V. The old server is gone because we destroy the resources. So this is new server. What's going on? Working. Let's connect. Find out why it's not. Control C. That's my terminal. All right, so we'll go to PowerShell. Clear the screen. Then we'll do fresh connection to our Jenkins server. Yes. All right, so that is connected. Now, so what's the next thing? Now let us browse the Jenkins server. Why is it not browse? Oh, 88. It's correct. Is it not our Jenkins? Let's try. Let's check. Are you not Jenkins? Let's ask it. Jenkins minus version. Hey, Jenkins now. Why are you not connected? Go Control C. Then we go to browser. Then we go Control V. Yeah, it's working now. So we'll quickly go there and pick the password from there, Ctrl C. Then we do what? We'll do cat, Ctrl V, select the password, C, then present it, Ctrl V. Then plus suggest. All right, let's do admin, 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 manager, the icon, the, I'm not saving anything. All right, so the first thing we want to do as soon as we enter Jenkins is define our tools. So manage Jenkins, tools, add Java, call it my Java, and then put the URL to my Java. Let's find out what the URL is. Maybe minus version. And then we say this is the URL to Java. Ctrl C. No. Control V. All right. So what about Git? Nothing. What about Maven? Add Maven. Let's call it my Maven. And then we just start. All right. So we have done that. So what is the next thing we want to do? This one, can we finish it? Let's look. So let's quickly set up all of these pipe plugins. We need them for this project. So go to dashboard, manage plugins. Let's do pipeline, Docker pipeline. So let's quickly go there. Go to dashboard. Then we go to managing. We go to
Plugins.
did you see? Yeah, plugins. And then we say available plugins. And then we say manage. What did we say?
Manage. Manage.
Docker.
No.
We install Docker. Let's see what other one. Docker build pipeline, Docker pipeline, Docker pipeline.
Publish over SSH.
Let's take it over. Okay, let's install this one. Then the next one we want to do is Docker pipeline. Let's take build pipeline, publish over SSH. This one's are installed, so we'll go back one step. Build pipeline. All right. That's done. Then we'll do publish over SSH. All right. What else do we need to install? SSH pipeline. SSH pipeline step SSH. Let's install this one. Step back. SSH agent. SSH pipelines. All right. So I guess we've installed all of the those that we need. All right. So what's the next thing now? So let us define the pipeline. So for pipeline, we are going to replace the server, the Docker server with the actual Docker IP address. Yeah. I'll be able to finish something. before two servers can communicate with each other, what we must do something. What is it that we must do? Anybody? You know, there are two servers here right now, right? The Jenkins server will build the artifact, and then it needs to transfer the artifact to the Docker server so that the Docker server can convert it to image and then deploy it to operation. So for that communication to exist between the two servers, we must first of all do something as technical guy. What is that we must do? Otherwise, two servers cannot communicate. Anybody? Can you hear me?
I think we have to SSH into both servers.
We have to establish SSH connection between the two servers. All right, that's good. So we must first of all establish SSH connection. There has to be SSH connection link, SSH link between the two of them. Correct. That's what she was trying to say. All right, so now that we know exactly that, let us go and do that. How do we establish SSH connection between the two of them? Do you have that in your note? How to establish SSH connection between Docker and, yeah, so let's do it. So let's do it. So we'll come back in. So we have one server, and this server is our Jenkins, right?
Yes.
Right. So what about the other server? Let's connect to the other server. So we'll go to our PowerShell, and then let us connect to the other server. So let's get the parameter for the other server. Docker server. Right. So we are going to use this same formula, but this time we'll be talking about Docker server. So we'll remove the Jenkins server and put the Docker server. So let us SSH to Docker server and proceed to PowerShell, Docker server. Yes. And that is good. We did it. So we are going to change this name to Docker server. All right. So like somebody was saying, to establish SSH connection between, so while we are at Jenkins server, we are going to run this command. Remote destination of artifact is the Docker. All right. So when we say remote, we mean Docker server. When we say source, we mean Jenkins. So at remote, we are going to run this command. So let's quickly run this. Control C. We go there and we stay at remote. Docker server is our remote. You know why it's remote? Because as far as the artifact is concerned, this is not where the artifact is manufactured. The artifact is manufactured in Jenkins and it will be thrown to Docker. So this is the home, the source of the artifact. This is the remote. So that's why we're calling it remote. So sudo, and then we'll look for, what are we looking for? Password authentication. Yes. Then we save. To save it, colon WQ. All right, so that is done. And then the next thing is to restart, Control C. Then we'll go and restart that. And then once that is restarted, the next thing is to change the password for our Ubuntu, Control C, so that when they ask us for password, we know it. We'll come back here and we'll say password is changing to the akin 2024 hash. The akin 20 the akin 2024. All right, so that was good. All right, so let's go back to source now. And at the source, we are going to say SSH keygen, Control C. What's the source of our artifact? The source of our artifact is Jenkins. So at Jenkins, we see SSH keygen, and then we do enter, enter, enter. Then after that, what do? Having generated the SSH key, the next thing is to copy the keygen from this server to the remote server. All right? You already understand the concept behind this. So Control V, to copy this to the remote server. So where is the remote server IP address? Control C, then Control V. Control C, then we'll come here, and then we'll do that. Are you sure you want to copy this? Okay, so what's our password then? If you are the right person to do this. The time 2024. Awesome. That was successfully copied. Now our SSH connection is established, just like the lady said. So if we try now by entering this command, it should work for us. All right, it says login successful, SSH connection. All right, so we have successfully established SSH connection. We have tested that it's working. Because right here, the IP address that we were sitting on was 196, but we have changed now to 46, so it's a difference. So let's close that before we forget. What's the command to close? Either close or exit. Any of them will do. We just say close. All right, so no, it says that's wrong. Okay, I'll just do exit. All right, so log out, exit or log out. Okay. So the connection is now closed, so we are back to our original. All right, beautiful. The fact that you knew that we should use SSH, that was impressive. Now we have done it practically. All right, now we have SSH connection established between the two servers. What's the next thing we want to do now? Let us now set up our pipeline so that our pipeline can now create the artifact, convert the artifact to image, and then deploy the image to operations. Everything will be done for us by the pipeline. Awesome. All right, so let's go and create it now. So this is the manual way of doing it. All right, so let's jump the manual. We've done enough manual.
We need to jump it. I said we need to jump it.
Okay. So let's go and do the automation is long, but let's start. Let's just start. So copy this whole pipeline, Control C. All right, Control C. And then we'll go and create a pipeline here. And then let's create it here, a new file. And then how do we create pipeline? We just call it pipeline. Dot what? How do we normally say pipeline? It's just pipeline. Control V. We don't say. Oh, sorry. We should save it as
There's no extension on just a pipeline.
Actually, we should save it as Jenkins file. Jenkins file.
I mean the name of the file.
Yes, you should must save it as pipeline. No, there's no extension.
Okay.
All right, so let's continue our editing. In fact, I should put that in the pipeline will build the artifact, then it will do everything with it. Do a lot of job. Let me tell you here that it should save it as. Okay, so we need to edit the code. So here, the IP address of the server. So let's change it to the actual IP address of the server. So we remove this. And then of the Docker server. Oh, So let's get the correct IP address of the current Docker server. It's right here. So Control C and then Control V. All right, so the Docker user remains Ubuntu. The Docker Hub repository that we are building will be this one. Okay, that's fine. So the Docker Hub credentials, to be able to, now you need to watch out here. The Docker Hub credential to access this remote repository, we need to build it. Docker Hub credential. All right, so let's go and build the credential so that we can supply the username and password for Docker Hub ID. All right, so let's go. Let's go to Jenkins. This is definitely an interview question. We'll go to Jenkins, and then we'll go to dashboard. And then we are going to go to build, manage Jenkins. And here we are looking for credentials. We want to define our credentials. You see the credentials anywhere here? Look at credentials. Yes. Okay. So we see configure credentials. All right. Global credentials. And then we want to add credentials. We want to add username and password for all of that. So for our Docker, where's my Docker Hub? My Docker Hub. Access my Docker Hub. My username and password. Username and password. Pick anything from my Docker Hub. Use the add Docker Hub credential to Jenkins. This is where we are now. Add credential. In the drop down, we take username and password. Fill the username for your Docker Hub account. Do I remember mine? All right, so my username for my Docker Hub account is the akin, and then the password, which I initially forgot earlier on. I later found that to be. All right, hopefully that is correct. And I'm just going to call this my Docker Hub ID. All right, so I've created the credential for my Docker Hub. That's good. All right, which other credentials do I need to create that the system will automatically need to be able to complete this task? The other credential that I need to create is SSH credential, ID. Wow. Wow. Very cool you are. Okay, let's try. SSH credential ID. Let's go and do that. So let's go back to credentials. So we'll say add credentials. This time we are going to SSH credential. Okay, so that's it. So the ID will be SSH credential ID. The username for my SSH, my username for my SSH to be able to, username will be Ubuntu. SSH credential, username will be Ubuntu. All right, so username will be Ubuntu. All right, so what is the private key? I'm going to enter my private key here. All right, so add my private key, put it here. Let me show you how to get private key. All right, so add the SSH credential to Jenkins. So you go to Jenkins server, can you see it now? And then when you get to Jenkins server, you go to .ssh, and then you pass. All right, so that's how to get the private key of your Jenkins. So let's go to our Jenkins server. This is complex, right? Yes.
Yeah.
But if you can know it, then there's no interview that you cannot pass.
It's what it will. doing that manual stuff, putting this one, putting that one, putting this one.
No, that one cannot give you a job. This is the real thing.
Mm.
All right, so we'll go to our Jenkins server because we have two servers. Make sure you are in the Jenkins server. So we now say cd dot. Let's see what we have. ls minus LA. So we see dot SSH, cd dot SSH. And then we'll now say cat our. Oh, this is it. Okay, let's copy it. Let's copy our private key. So make sure you copy from end to end, from the very beginning to the very last one. Okay. All right, Control C. Then you present that exactly as it is. So Control V. All right, so now you have it. What's our passphrase? What's our password to Jenkins server? Our password is the item, the item. Move that once so that we don't need to be troubleshooting up and down. And then there's one more credential. What about the credential? This is the credential for Jenkins to access our image repository. This is the credential for Jenkins and Ubuntu to communicate with each other, knowing that, oh, it's me now. And then what about the credentials for our GitHub? Let's quickly add that one. Our GitHub will be username and password. Let's present a username and password. Yeah, our GitHub. And then we'll say the item. And then don't display my password or my item is Control right here. Control C and then Control B. All right, so the ID, every time I'm calling this, I'll simply call it, let me look for consistency, I'll use the same name. Where's my GitHub? GitHub, Docker credential, the item. Okay, I'll simply call it the item. It's not registered. Okay, it's not there. So when you want to call this one from a private repository, it will require credentials. So that's the credentials I am providing as the item. The item, I'll just call it. All right. All right. Hopefully it works. Sometimes it doesn't work the first time. It will tell you error, and then you have to troubleshoot and find out where did you make mistakes. So these are the three primary credentials that you need to present, just like we have them in the notes. Like we have them in the notes. Yes. Awesome. We have them here. So we presented our GitHub credentials, our Docker Hub credentials, and our SSH, those three. All right. So we've presented, we've created them. All right. So we have created them, and then we have used that creation to define these variables for our pipeline. All things being equal, our pipeline should run. But if it doesn't run, then it means that we have so here we put Ubuntu, and then maybe I should have told you what we are providing here. Here, and then where the passcode is. In that direction. Okay. All right, so as far as I can remember, that's everything now. So unless we run it and run into problems, we will not be able to troubleshoot what we have missed. All right, guys, let's go and run our code. So to run this code, we'll come here now. Control S. So we'll take this whole code. Instead, that will push the code from here straight to our GitHub, or we Let's take it, Control C. Let's go to our GitHub and just paste the code, because let's see if we can finish this thing with it. So which code do we want to build? Let's find out. Which code are we building? Let's do it. So, our code. We are building GitHub, the akin, DevOps basics. We are building DevOps basics, right? The akin DevOps basics. Okay, so let's go there. We'll go to GitHub, the akin. Oh, this is the code we are building, DevOps basics. Okay. So since this is the code, the equivalent of that one here is Jenkins file. We don't call it pipeline here. We call it Jenkins file here.
Okay.
Exactly. So look at
Okay.
Jenkins file. We are just going to replace this code here, which was the last successful one that I implemented. I'm going to edit this, and then I'll say my code has changed, and then I'll put this new one that we just. All right. Then we'll say confirm. This is save. All right. So everything that we need to build to do the deployment of this code is already inside. To build the deployment of this application is already inside this CI/CD pipeline, and everything has been uploaded to cloud. So my work now to GitHub, my work now is just to run this code and run it successfully, and the deployment will complete automatically. All right, let's go and try it and see if it works. So go to Jenkins now. We'll go to Jenkins. Where's our Jenkins? Onto Jenkins. And then we'll go to dashboard. And then we'll say build a new project. This time, we're not building freestyle, we're building pipeline. And let's call this pipeline. What name do you want to call it? Projection. All right, so we'll say pipeline project, which is the height of all of that. And we're going to say, we're not declaring anything here at all. Everything you need is already provided for you. Just go straight to GitHub, and then go to source code manager, use Git, and then go to the particular code that we are building, which is this one. Control V, and then it's saying error. I've already defined it. Use this one. Oh, that one worked. Fine for that one. And then it's going to ask you, where is the file that contains all of the instructions that I'll use to run this pipeline? You see, it's inside Jenkins file. We already saved it in there. That's it. We apply and we save. All things being equal, we are now ready to run our pipeline. All right, so let us build now and see whether it works. We are building our pipeline. Please build now. And then we can now look at build, edit, build, pipeline overview. So our pipeline is running. So far, so good. Compile, working. Pipeline. Package is working. Wow, everything seems to be working. Wow. So the Docker was built. The file was successfully copied from Jenkins to Docker. So Docker is now building. Wow. Oh, something failed. Okay. All right. So far, so good. But at the point of pushing Docker to our, let's see, at the point of pushing Docker to our repository, something failed. Docker password, that password that I entered apparently is not correct. Okay, so we'll just come back and then we'll complete this troubleshooting. But it's normal to face, I mean, look at the extent of work that we do. So it's normal for us to face issues.
We really went far.
Yeah, so it's normal for us to face 1 or 2 issues that we need to resolve before we come. Otherwise, it will be too much. All right, so we just come back another time and then we'll find out what did we do wrong? Which password did we not get right? We just do that right and then everything should work normally. So that is not happening. So it is the concept and the steps that we followed that is really important. All right. For the rest of us, I know Richard has been asking. The rest of us, did you manage to understand what we did?
Yes, it's quite different from what we did in class, but
Yeah, this is way. I think this one is way more better because it's code.
yeah, I think in class they kind of broke it down so we understand all the steps, but this is more advanced.
Advanced, yeah.
I prefer this.
Yeah.
I prefer this one.
Yeah, you needed all of those breakdowns to be able to understand this complexity.
Yeah.
Even the interviewer may not even understand it to this level, so he will definitely be impressed if really can. Even if this was the only experience you are taking to interview, as far as the interview is around CI/CD, unless it's around Kubernetes or something else. Yeah. So if it's around CI/CD and you present this one, you're good to go.
I remember asking exactly what was the purpose of that Jenkins file.
Oh,
because
okay.
the repository we used for practice in class, it had a Jenkins file, it had Docker file, it had webhook file, it had pom.xml. So I was asking, what is the purpose of all these files in the repo?
Okay.
Because we did all the work on Jenkins on the browser like you're doing now. So it's actually one of the questions I was going to ask, like, of course, when I get the repository from the developers, it will contain the code.
Yeah.
So I'll be responsible, as the DevOps person, will be responsible for all the other files that will automate the process. So can we actually get like drilled down to the basics? What exactly, we're going to need to add to the repository?
And that's not entirely correct. So,
okay.
Yeah, all of these other files, you are not solely responsible as the DevOps engineer. So, even though your own contribution will be mainly around Jenkins file, it may not be completely 100% your work. It could be like 70% and then 30% contribution from your other team member. So in one word, all of these files, the impression you had was each person will do its own part and contribute, and then they will leave you to do. No, everybody will work together to get all of the files. So your own work will now be, now that all of the files are complete, you have gotten the Docker file from developers, you've gotten the XML from the right people, you've gotten all of the files are complete. Now you run it. If you run it and you run into a problem like we just did, and it's not something within your jurisdiction to resolve, you come back to the team and say, look at our work, I'm not able to run it. Everybody will put heads together again and resolve it, and then push the new code to the repository, and then you run it again. So there is always the team to work with you.
The Docker file. I'm sorry, I don't mean to cut you off. You said the developers will be the ones to provide the Docker file.
Yes, you work with them to provide it. Yes.
Okay.
Yeah, the POM. Yeah, we used to trouble ourselves. POM.xml is not working, and Docker file. We will be struggling up and down. And then, I mean, at those initial stage, like 5 years ago, 4 years ago, and then we came to a point where we actually did live work, and we so it's not really our work. Then there are at least 7 people on this team. At least 7 people. Remember that another thing that will put your mind at rest. Before these codes were ultimately pushed to this central repository, each of the codes have been tested and run on local systems by the developer. So it is what worked for each of them at the local system that they are now pushing to the central place. So this is what worked for me. So you couldn't have done this thing by yourself on your own without them, first of all, testing it on their local systems and it worked before submitting. So how would you know what worked for them if they did not contribute what worked for them to the central repository? I don't know if that makes sense.
I understand now. It's much clearer now because I was very confused with this with this repository.
Yeah, it will be so much if only you have to. So all of these 5, they are all, remember that is why it's central and available to all team members. By the way, do you know how to write it down? We'll do it in next class if you do not know how to add members to this team. So this is not only available to you, it is available, the Scrum Master has given you access just like he has given other members of the project access by coming here and by saying collaborators and then adding, you see all of these people? Abayomi, Adebayo. In fact, I'm going to add you guys as well. So these are all members. So it's not only you that have access. Everyone has access to be able to make modifications. So it's just a matter of you telling them, I need you to do this, I need you to do this. Or I do not even know what the problem is. This is the problem. Everybody puts that together and then we'll resolve it. Yes. Otherwise, it will be too much work for just one person to be able to resolve all the 5. All right. It's good to know that this project gingered you. So whoever was not talking is talking now because you were shaken by the project. Right? All right. So we'll have one more session where we'll resolve this issue together. This is something I can do on my own, but I would rather wait for us to be together and then we'll resolve that and then we'll not keep into. So if you share your email address, I can just add people and then I'll just put your email here. So it means that you will now be able to make a copy of this repository and then you cannot claim it. You cannot practice more and then you cannot claim it at interview as the work that we have done. So make a clone this repository so that you can practice it and then you'll be able to run it from here like you are watching me do now. You should be able to do it by yourself.
Yeah.
All right. I'll be on for today.
It's in the chat right now for you.
No, let's do it on WhatsApp.
Okay.
Yeah. So that's it for today. So let's meet one more time on what's today? Today's Tuesday, right? What's Monday? Let's meet one more time on Wednesday.
Monday or Wednesday?
Today's Monday, right?
Yes.
Let's meet on Wednesday.
Okay.
Yeah.
Same time?
Yes, same time.
Okay.
Yeah, please just when you're done, please just send it so that we can practice it before you come.
Yeah, I'll send it. I will share it right away. So just leave your name on the your email address on the WhatsApp group, and then I'll share it with you. Once I share it with you, you know how to clone the repository. You clone it, and then I'll share with the email address you are sharing on the WhatsApp group. I'll also share my notes with you so that you have the note, you have the video, you have the repository. So you have everything.
I have one last question. Do you have any tips on how to use ChatGPT to generate this?
No, but it's very, very simple. We can look at that next. Just generate the prompts. And then I can share some of the prompts that I have used to generate some of them. No, I do not have any tips or any recordings.
Okay.
That's called prompt engineering. No, we don't. It's too simple to. All right, guys. Thank you. See you on Wednesday. All right. So stop.
All right. Thank you very much.
Thank you.
Yeah, thank you, sir.
Welcome, everyone. Yeah.
Have a good night.
You too.
Bye.